Hi class, we're on 11.4. We are looking at Boyle's law, which involves pressure and volume. So Boyle's law involves pressure and volume. It's an inverse relationship. That means if you look at the box, one variable goes up and the other variable goes down. So if pressure goes up, volume goes down, and it'll make more sense as I show you the next slide. There are no change in temperature or moles. The number of moles of the gas remains constant. So nothing is added and nothing is taken away. We're only looking at pressure and volume. So here's an example of Boyle's law. So they are inversely related, which means one goes up, the other goes down, without changing the temperature, without changing the amount of gas. So if you look at V1, P1, and this is the formula for Boyle's law. 1 is the initial conditions, 2 is the final conditions. So in this case, we see volume 1 is 4 liters, and P1, which is pressure 1, or initial, is 1 atm. Now we look over to the second one, we can see V2 is 2 liters, and the pressure of the final conditions is 2 atm. So let's take a look at what happened. If we look at the volume, we started out with 4 liters, and it got cut in half to 2 liters. So if volume is cut down, then that means that the pressure must increase. So volume was decreased, the pressure increases, and that's exactly what happens. We go from 1 atm to 2 atm. So the pressure increase. So what this is, if we're looking at just the pictures, we have molecules that are spread apart very far, not a lot of molecules, and so less chance of collisions because they're not reinforced to interact with each other. And remember, collisions even with the surface, because there's a lot of room in there, there's less collisions with the surface, and the collisions are what cause the pressure. As you compress the gas, now they're forced into a smaller area. They're forced to interact with each other. They're forced to have more collisions. More collisions increases the pressure, and that's exactly what happens. So this Boyle's law was discovered by Robert Boyle, and of course he named it after himself. It is at constant temperature and constant number of gas particles. So neither one of those is touched when we're going to do problems regarding Boyle's law. You'll also see this here, and this just means the volume is inversely proportional to the pressure. So this is where one goes up, the other one goes down. But this is the formula. So let's take a look at what I've been saying. So here's a J tube, and the J tube has mercury in it. And this is a gas volume here. The gas cannot escape because mercury is so dense so it can't get through it. But if we added more mercury, what it does is it pushes and compresses the gas from this large area to a very small area. So if it's pressing, if the volume is decreasing, that means that the pressure has to increase. And it does when you look at this graph here, that you can see that this is very low pressure, this is very high pressure, and you can see the volume just really decreases as the more pressure is put onto the gas. And this is the same picture, it's very similar to what I showed you on the other one. So kinetic molecular theory explains the observed changes in the pressure, meaning if one variable, either pressure or volume, goes up, then the other one has to go down into a smaller, so volume, if the smaller volume is smaller, then it causes more collisions, and that collisions then increases the pressure. So let's do some problems. A cylinder equipped with a movable piston has applied pressure of 4 atm and a volume of 6 liters. What is the volume of the cylinder if the applied pressure is decreased to 1 atm? So I want to point out a few things here. You're given 3 variables. You have to solve for the 4th. All units should be matching. So whatever is pressure, those units should be matching. Whatever is volume, those units should be matching. If you are given a problem with different units, you need to convert them to the same unit to do this problem. So in this case, we're working with atm for pressure, and we have liters. So our answers should be in liters for this last one because the atm units will cancel out. So we need to find the volume. Now you should have an idea of whether this should increase or decrease. So looking at pressure, our pressure decreases from 4 atm to 1 atm. So if pressure is decreasing, then we expect the volume to increase. So we plug everything in. I always suggest that you write everything out so you know exactly what you're dealing with. It is really easy to plug them in wrong here because you write these in wrong. So make sure you double check what you're writing when you're dealing with this. So we solve for V2, and we end up with a volume of 24 liters, and that makes sense because remember, if one goes up, the other goes down. And that's what it means to check your answers. Just check that you understand that in this case, the volume, you expect the volume to increase because the pressure decreased. So here's another problem. Freon. What is the volume of an 8-liter sample of Freon gas initially at 550 millimeters mercury after its pressure is changed to 2200 millimeters mercury at constant temperature and volume and moles? So here we have pressure again and one volume. Same units, 3 variables. So we need to get the answer for V2. Again, we see that the pressure is increasing, so that means that the volume has to decrease. That's what we expect, a smaller number. And if you don't, this is a good idea to make sure that's where you understand how you wrote this out, because maybe you wrote the wrong pressure with P1 or P2, you transposed them. So in this case, we end up with a volume of 2 liters, and that makes sense. The volume decreased because the pressure increased. Okay, so a sample of oxygen gas has a volume of 12 liters at 6 millimeters mercury. What is the new pressure when the volume changes to 36 liters at constant T and moles? So it won't always tell you constant T and moles, but this is where it's hard for students in the beginning. You have to understand how to read the problem. So look for the variables and understand what it's asking, and that should help you understand which way you have to solve this problem. So in this case, let's pull everything out. We are being asked to just solve for P2, the new pressure. So we're given variables of P1, V1, and V2. So if we look at the volume, we can see that the volume increased. So if we know that the volume increased, then that means the pressure has to decrease. So plug everything in, and we end up with 200 millimeters mercury, and that's right, because the volume increased, meaning there's less pressure on it, on that container of gas. Okay, so I got a few more problems. For a cylinder containing helium gas, indicate if cylinder A or cylinder B represents the new volume for the following changes. So if the pressure decreases, are we looking at A or B? And if the pressure increases, are we looking at A or B? So let's take a look at the answers. So cylinder B, if the pressure decreases, then that means it has more volume. So the less collisions, and less collisions means less pressure buildup. If the pressure increases, we're looking at A, because that means that the molecules are in a very small confined area. They're forced to interact with each other and the surface, so thereby there is more collisions, more pressure. And the last problem, if a sample of helium gas has a volume of 120 mils and a pressure of 850 millimeters mercury, what is the new volume if the pressure is changed to 425 millimeters mercury? So again, pull out the 3 variables. Units have to match. Take a look at what's happening here. We start with a pressure of 850, which is high. It is decreasing to 425. So that means that the volume must increase. So we expect a volume larger than 120 mils. And we do. We get 240 mils. So that matches what we expect to happen. Oh, one more problem. A sample of helium gas in a balloon has a volume of 6.4 liters at pressure of 0.7 atm. At 1.4 atm, is the new volume represented by A, B, or C? So the thing you need to look and understand here is pull the variables out, and the variables that have to say that you can compare, look at them. So in this case, we're given pressure. So we have a pressure at 0.70, but it increases to 1.40. So if the pressure is increasing, we expect the volume to decrease in this case. So at higher pressure, the new volume is represented by smaller balloon A. Because the pressure increased, then we expect the volume to decrease.